In this video we're going to go over question 2 of the Edexcel June 2016 paper. Apologies, this is quite late in the day. I'm kind of the worst student here. It's a few days before the June 2017 exam. It wasn't so much the first part, up to A, B and C and D, that was a problem last year. It was parts E and F, but let's just do the whole question anyway. So as I say, the first few parts are relatively standard. For part A, just the one question, we're using the fact that these add up to 1. Okay, so if we use that it just says write an equation. So we have, well, we can, so long as we write something with these totals being equal to 1, that's fine. I'm going to write 2p because we've got 2 of them, plus q plus 0.5 equals to 1. That's going to get us the mark, I'm sure. I might just simplify it for the next, because I'm sure we're going to be using that later. Take that over to the other side and get this equation here. Okay. And then part B, it says given that EX is equal to 0.4. Now EX is basically equal to sigma x p x equals to x. In other words, this time the total of this times this, this times this, this times this, this times this, and this times this. So we can just use that to get another equation, and hopefully we'll get the value of q or a simultaneous equation. We'll see what happens. Anyway, so we've got minus 2p, that's that times that, minus 1 times q, let's just write that as minus q, a half times 0.2, 3 over 2 times 0.3 plus 2 times p, 2p, equals to the thing we're given, which is 0.4. Okay, that's okay, isn't it? Because what's quite nice here is that p cancels, so we don't have a simultaneous equation after all. P is going to go straight away. So let's tidy up the rest of it. We have minus q equals plus a half of 0.2, which is obviously 0.1, plus 3 over 2 times 0.3, that's 0.15 times 3, which is 0.45, and that equals to 0.4. So we have minus q equals to 0.4, take 0.1, take 0.45, so it gives us minus q is equal to minus 0.15, so q is equal to 0.15. Okay, so that's, let's say, relatively standard stuff so far. Part C, well, we can use our original equation here, now that we know the q. So we have 2p plus 0.15 equals to 0.5. So that gives us 2p equals to 0.35, which gives us p is equal to 0.175. Okay, so part D, there is a formula for the variance or var of x, which is the mean of the square minus the square of the mean. Good way of remembering this. But now we've already got EX, so we know and we're given EX squared in the question. Just try to test whether we can use a formula without giving us quite a lot of information. So that's 2.275, and we already know 0.4. So 0.4 squared. And that gives us 2.115. No problem. I think not really much problem up to that point in this question. Problems where they came on the next few bits. Okay, so for this, it's a little bit of context to it, and it's given us some information about r is equal to 1 over x. So there's some kind of strange competition these two people are having. So in Rebecca, where one has the reciprocal of this score which is a reciprocal of the x distribution that we've just worked out up here, and the other one that has actually that distribution itself, where s equals x. So write down the values that we had of x from before. Now here Sarah will just have the same score, something like that, just out again. But Rebecca will have the reciprocal of that score, so the reciprocal of -2 is -1/2. The reciprocal of -1 is -1. The reciprocal of 1/2 is 2. The reciprocal of 3/2 is 2/3. And the reciprocal of 2 is equal to 1/2. And here we've got the probabilities, x equals x, or indeed probability s equals to s, or probability s equals to r equals to little r, same thing. All got the same probabilities because they all relates back to whatever x is. And they're the values that we had from before. So this is how we're going to find ER. So we're just going to use the same formula we did before. So that times that, plus that times that, plus that times that, plus that times that, plus that times that. Sorry, the one below it, of course, but you get the gist. That times that, that times that, that times that. Anyway, just before I do that, because it's pretty straightforward, I suppose the obvious question, and I think some people made this mistake last year, was why can't we do this? Why can't we do that? And some students did that. I suppose it's the wrong question. We should be asking the question, if we think it's true, why can we do it? Okay, it's the wrong question. It's not true. Okay, so that's wrong. Okay, wrong. But what is correct, let me rub that out, if it had said something like r equals to 2x plus 1, well, we do know things about the linear functions of a random variable, that it comes out like this. So that's okay, because it's a linear function. But we can't do that with any old function. There is a little trick we can work with it with ex squared using the variance, which avoids doing, redoing the distribution. But otherwise, we're going to have to do the whole thing again. So unless it's linear or we're using the variance with the x squared, we've got no choice but to go back to first principles. So I hope that. Apologies if that didn't seem like an issue to you, but just it was for some. Okay, so we've got e to the r is equal to -2 times 0.175, not -2, let's read the right ones, I've written too many numbers here, -1/2 times 0.175, and then -1 times 0.15, and then 1/2 times 0.2, no, 2 times 0.2, it's that times that, 2/3 times 0.3, because we're looking at the R ones, and 1/2 times 0.175. Okay, I'm working all that out. That comes to 0.45. So that a little bit less standard, we have to rewrite the distribution with the probabilities and start again, and there's no shortcut to it. Okay, so that's part E, and then part F, even less standard again, I would say, probably. First time I read this, I thought, oh God, I'm not sure. What? Occasionally it happens. I think I read too much into it because I didn't really realise it all relates back to whatever x is drawn. So these are very connected, these two. They're not two separate distributions, S and R, in which case the question would be far more complicated, where we'd have to look at combinations that would work, where S would be greater than R. They're all related back to whatever number x is drawn. If that seems a bit, if I'm talking gobbledygook, then perhaps you can ignore the last 30 seconds, but certainly I got into a bit of a tiz about it until I read the question again. So really, if -2 is drawn, then S scores -2 and R scores -0.5. And in this case, we can say that R is greater than S. So anyway, Sarah wins if S is greater than R. And that will happen. Well, doesn't happen here, because in this case, R is greater than S. -0.5 is greater than -2. It's not true here either, because they're the same, and that would be a draw. It's not true here either, because R has scored more than S, because that's 2.5. Okay, R is good, but here it's definitely true. S is greater than R when the number X drawn is 3/2. So that's 0.3. Okay, plus this one as well. S is also greater than R. Under these circumstances, if 2 is drawn, then S gets 2 and R gets 0.5. So we're adding that on as well. So that gives us 0.475. Okay, and a similar process. Once you've got half of these things are how to do in the first place. Once you've worked out the method, carrying it through is not too bad. R greater than S. Don't do 1 minus this, of course, because we've got the possibility of a draw. Could use that as a check, I suppose, because when we work this one out and add them together and put 0.15, then it should come to 1. But we're now looking for when R is greater than S. As I've already said, it will be this one here, that's 0.175. Not this one, because that's a draw. And this one, plus 0.2. So that's equal to 0.375. And say as a check, to check that these are right, add those two together, we do get 0.85. Which allows for the possibility of a draw, which is 0.15. Okay, that's a little bit less standard at the end, but not too bad. Okay, hopefully I have time to upload a few more questions before the exam. Bye.